Welcome to the Citus 11.1 release party. It's our second ever release party with live demos from some of the engineers on the Citus database team. I'm Claire Giordano, and with me today is Sai Srirampur.
Hi, Claire. Very excited to be here. And I see Citus 11.1 as a very powerful release. I was chatting with Claire just before the live show started because there are many critical features in Citus 11.1 which are now completely online, right? Like you can create distributed tables, you can isolate your tenants with no impact to your application. So I'm very excited for all the demos that are in store for us. So yeah, Claire, welcome everyone.
Yeah. Sai and I have both been involved with the Citus open source project for many, many years. Sai actually longer than me. I started back in 2017. And a lot of times we'll publish blog posts. Teresa, if I can share my screen for a second. Oh boy. This is the GitHub repo for the Citus open source project. And Citus is, of course, an extension to Postgres. But historically, we've just published a blog post for each of the new releases. And this is the blog post that Marco Slot, who's our technical lead, published. But I'm pretty excited that we're going to take all of these internal demos that we used to share inside the team, and we're going to live stream them all to you guys here today.
Yep.
So before we dive in, should we walk through the release notes? This is also on citusdata.com. There's an updates link in the top nav on the open source project website, and it'll tell you for all the various latest releases, kind of the detailed nitty gritty, what's new. Even more detail that is in the blog post. And today, Sai, talk to me. What are we going to cover? I guess the first thing is this guy.
Yeah, create distributed table concurrently, right? So this actually helps you scale from a single node Postgres to multiple nodes by transparently distributing tables in an online way. So you have this ability to start with plain Postgres, and then with the superpower of distributed tables, scale out in place with no impact to your application, right? So previously, create distributed table before this release was a blocking operation. It blocked writes, it didn't block reads, but now this is going to be all online and it uses logical replication. So I think Adam is going to talk about this. So yeah.
Yeah, I think he'll give a demo. And then after that, Nitish, who's here with us today, is going to give a demo about tenant isolation without blocking writes as well, correct?
Yeah, absolutely. And as you know, Claire, I think multi-tenant SaaS is one workload that we see a lot with customers. And one feature that has existed in Citus since long is the tenant isolation feature, which lets you, isolate these hotspots, isolate large tenants to their own nodes, and so that you don't affect the other tenants, and this tenant gets its own dedicated hardware, and you can scale out, right? And that particular operation was not online, but now with this release, tenant isolation is all going to be online. So as your application is running, you can just isolate this hotspot, isolate this large tenant to their own node with no impact to your application, right? So I'm very excited about this personally because SaaS and multi-tenant is something that I see on the field a lot, right? So yeah.
And that's something I should point out that you, Sai, have spent years working directly with customers, first as a solution architect. Now I know you're a senior engineering manager, but you have been out there kind of in the field working with people on their data model and on the architecture and figuring out how they can achieve distributed scale for their applications. So I think the whole day today, all of your comments and things that you're going to interject are probably going to be from that customer angle.
No, absolutely, Claire.
And then tenant isolation, it's always been a feature. Well, not always, but for a long time, it's been a feature in our enterprise offering and in the managed database service on Azure. But in the last release, it's fully open source. Citus is completely open source now, correct?
Yep, absolutely.
Okay, awesome. And then I think Nitish is also going to give a quick demo on shard splits as well, right?
Yeah, absolutely.
In a non-blocking way.
Yeah, and this is a powerful feature because I get in the field, there are many questions a customer asks whether I can, change the shard count, right? Citus has this concept of a logical shard which is present on the nodes. I mean, it has multiple shards across nodes, and customers ask that, can I change the shard count? And now this feature, splitting shards, lets you, change the shard count all online and gives you more scalability, right? So this is another feature I'm excited about. But yeah, let's see what Nitish has in store. So.
All right, and then before we scroll further down to what owner is going to demo, I just want to highlight that in Citus 11.1, we have Postgres 15 beta 4 support. Obviously, Postgres 15 is not yet GA, but it should be come October, right? The release candidate 1 comes out this Friday, right?
Yeah.
So that's good to know. I mean, that's one of the great things about being an open source extension to Postgres is it makes it so much easier to stay current with the latest and greatest Postgres releases. And then let's see the topic for, rebalancer in the background, right? That's what owner is going to demo to us today. Cool.
Yeah, absolutely. And this is also a very important feature, right? This is the scale story for Citus. So you have a few nodes and you want to seamlessly scale out. That is where the shard rebalancer comes in, and it helps you scale out in an online way. Shard rebalancer existed in Citus since many years, and recently, as you pointed out, Claire, we went all open source. So like shard rebalancer is also open source now. And with this release, which is 11.1, we're going to make it more performant and more usable, right? So this is one demo which will be exciting, right? So let's see what Honor has in store for us. But yeah.
Okay, and then I'm popping the GitHub repo back on the screen too, because as someone who's worked on this project for years, I am thrilled whenever new people discover it, whenever new people star it. And so I just want to make sure everybody knows where to find this. I think you can get there from aka.ms/Citus if you want to go check it out, install it, download it, poke around and give it a try later. With that, I think if we could pop up my slides, I think that will show a list of the 3 demos that we're going to show. And the person that I'd like to welcome to the screen right now is Adam Vogt. He's a product manager on the Citus database engine team. He's joining us from Poland today, right?
Yes, correct, Claire. Thanks for having me. So hi, everybody. I will be talking about the create distributed table concurrently functionality that we added in this release of Citus. As Sai mentioned, we made a lot of effort to make online operations of scaling out much easier in this release. So if we could bring up my terminal. Okay. What I will be doing is showing you how to go from a single table, and I'm going to create it quickly here. This is just a plain table with a tenant ID field, measurement ID, payload, which is a JSON-B column, observation time, and a primary key defined. And we will generate some random data for this table. And this will generate around 3 million rows. And imagine it this way. You are either starting out with a single node PostgreSQL Citus cluster, and you didn't expect that the observation table would grow so large that you would need to distribute it. Or perhaps you just didn't expect your business to grow this fast that you will need to do it. So we are in this situation that we have this table, we have 3 million rows loaded into it, and now what? Before the 11.1 release, you could use the create distributed table UDF, which is a user-defined function, to distribute this table. But as Sai mentioned, that operation was blocking. So let's not simulate that, but let's actually do that. So we have the table with 3 million rows on the left. We have a connection to the same database cluster on the right. And on the right, I will slowly insert every second a row into this table. This is just an insert into observations, the fields, one value, and repeat it every second. So we can see we are returning the measurement ID, so we can see the count of rows that we inserted so far.
Yeah, and Adam, Sorry to interject. One interesting fun thing is there is a JSON-B column also in the row that you're inserting.
Yes.
But yeah,
yes.
go ahead, Adam. Yeah.
So what I'm going to do on the left is called the UDF function that if you use Citus before, you probably know, which is create distributed table. And usually you do this on an empty table when you are designing your schema, so it's not a problem. But if this is your production and the measurements on the right are actual devices, and right now I'm going to execute create distributed table on the left, you will notice when I do that, I didn't yet, that the ticking inserts will pause. And I executed this. You can see it being stuck on 33. And we are done now. And the ticking is back up. So we lost about 6 or 7 seconds of writes in this table. And this is not a super large table. If we look at it, it's 219 megabytes of data. So you can imagine if this was gigabytes of data, then you have a non-significant downtime for your application. And we want to help you avoid that problem. And the work we did this time around, and I'm going to drop the table to have the same starting environment as we did. And I'm going to recreate it and regenerate the data.
So wait a minute. If you were, a lot of people, they create distributed table when they're first getting set up.
Yes.
So for them, it doesn't matter if writes are blocking or not blocking because they're not in production yet, correct?
Exactly.
Okay. So this is for the scenario where you're scaling out, you're in production. Maybe there's a new there's a table that needs to be distributed that you had as a regular table on the coordinator node or something like that, and
Yes.
you don't want to block writes. Okay.
Yes, and it might be a situation where your workload changed in a way that a table that didn't grow enough in your past, and you didn't expect to ever need to distribute it, but the situation changed. So now you have to face the reality. So what we did in the 11.1 release, and let's prepare the same thing on the right.
I just want to add one thing also, Adam, is Claire, you also get the power of, starting off with Citus with not distributing your tables. You just start with like plain Postgres, and then you have the ability to scale out in place, right? So you start without worrying of distributing tables, etc., on a single node Postgres, and now and your workload has grown that like it has outgrown that single node. You just like run this create distributed table, and in place your workload is now distributed, right? So that is another use case, Claire. Yeah.
To go from single node Postgres to a distributed environment with Citus.
Correct.
Yes.
Got it. Okay.
Exactly. So with this release, we introduced create distributed table concurrently. And this is similar in nature to how you would do concurrent index builds, for example, in PostgreSQL. So on the left, I will run the command. On the right, we will have the inserts executing, again, ticking every 1 second. Mm-hmm. And this time around, when I start it, you will notice that the inserts will continue. So I am starting it now. And you can see the inserts are continuing to tick. Every second we get an insert. So this means that currently the system is distributing a table, splitting it into shards, and moving the shards into other nodes, while the application is continuing writes, so you don't have any downtime. And you can see we are done. The inserts are continuing. I'm going to pause them now. We can see the count on the table.
Awesome.
They match the amount of inserts that we did. We can see, so there's this built-in Citus view called Citus tables, and it shows all the distributed tables. So you can see that we now have an observations table that is distributed using tenant ID as the distribution column. The table size matches, and the default shard count 32 because I didn't define any other. And we can also, because I'm actually demonstrating this on the managed service at Azure, so we can check how the shards are distributed among the nodes. So you can see that on private W0 worker, so on my first worker, we have about 150 megabytes of data, and on the other worker, we have 69 megabytes of data. So, this shows that the data was distributed among the workers while the inserts were happening. And you may ask why one of the workers is larger, why the data is uneven. And this is because I intentionally, when generating the data, introduced a SKU for one tenant ID, and we can quickly find it doing this simple query showing the count of tenant ID grouped by tenant ID, the 10 largest ones, and we can see that tenant ID 293 has significantly more measurements than all the other tenants. So this brings us to the next cool features that could help you in handle that situation. So back to Claire and Sai for now.
Adam, this is great, and I had a question for you, Adam. This might be a very
Sure.
naive question, but I do want to ask it. So, so why did we create a new function called create distributed table concurrently? Why didn't we just extend the existing function, which is create distributed table?
Ooh.
Yes, that's a great question, and it ties into we know that the new functionality has some limitations, and we know that the PostgreSQL community is used to the fact that, for example, creating indexes concurrently has some caveats that you need to be aware of, and we want you to be aware of some caveats when using to create distributed table concurrently for now, like you need to have a primary key replica identity on your table, or update and delete commands would fail during the concurrent distribution of the table. And this is due to the limitations on logical replication that we are working on a patch that we proposed to PostgreSQL 16 to address this. But for now, this is a limitation that we have to live with.
And I
You
know
also-
those details are documented, they're captured. Like if you go to that updates page, the release notes
Yes,
page
yes,
on the website
absolutely.
and the docs.
Absolutely, Claire.
Cool.
Yes.
And also the good news, Adam, is in most of the operational and transactional workloads, the primary key does exist.
Yes.
This is what I have seen in the field, but you can go ahead. So that is one caveat. Yeah.
Yeah, another one is you cannot use create distributed table concurrently in a transaction block, which means that you can only distribute one table at a time. Now, it's not a common use case to want to distribute multiple tables in a transactional way, but this is something we want you to be aware of before you try to do that in a large migration script and find out later during like your testing or production run that this is a no-no. And another limitation is that when the table, you cannot use this method when the table is referenced by a foreign key or is referring another table. You can of course have foreign keys to reference tables, and that will work. And you can create foreign keys to other distributed tables afterwards. But for now, you have to be aware of that limitation.
Well, Adam, I was going to thank you so much for joining us, because I know Sai would ask questions for another 10 minutes, but we have other people with other demos here, Sai. So
yes.
Unless it's super urgent, I think we should jump to the next person.
Adam, very interesting.
I'm so glad you're here. This is only our second ever Citus release party, and I'm really glad you're part of it. So Nitish Ipreti, welcome.
Hey guys.
Hey.
Thank you so much. So glad to be here.
So you're going to be demoing two demos, actually.
Yes.
First, tenant isolation without blocking writes, and then shard splits in a non-blocking manner as well, correct?
Yes. So yeah, let me jump right to it.
And I think Sai mentioned earlier how important tenant isolation is for like multi-tenant SaaS workloads, right?
Yeah, and also Adam kind of left you on a cliffhanger where we had one large tenant and we had to do something about it, right? So yeah, I'm gonna continue that. Cool.
All right.
So just checking if everybody can see my screen.
Yep.
Yes.
Cool. All right. So Adam just demonstrated how we can start with a local Postgres table and distribute it with a create distributed table concurrently. However, think about the journey beyond that. Once you have a table that is distributed, as your workload and storage requirements change, you might want to reshard. You might want to increase the number of shards that you have, or you might want to like isolate your large tenants, right? So that's where these two capabilities come in. And I'm going to demo that to you guys. So before we get into the actual new UDF that we have introduced, the new two capabilities, let me kind of refresh the scenario that we had here, right? So in this case, we had a table observations that had a few columns. I would like you to pay attention to the tenant ID column, as our table is distributed using the tenant ID column. So this is again the multi-tenant SaaS application, right? So let me kind of show you a little bit sneak peek into the table. So we have like a few rows here. I've just kind of shown you 10 rows to kind of get you a sense of how the table looks like. And now I'm just going to give you, show the pgdist node catalog, which kind of shows you the state of the cluster. Here I have a three node cluster running locally on my machine, but this should be no different in Azure or on-prem. So yeah, that's that. Now let me kind of show you the shards for the stable observations, right? So we are using hash distribution here. And as you can see, it shows me 32 shards. So by default, Citus has 32 shards when you distribute a table. So that's what we have here, just the vanilla setup. And then, each shard owns a hash range, and then like whatever your any item you insert in the table kind of gets hashed to one of the shards, right? So that's just the hash distribution in action, right? All right. So now let's get to something that's closer to the tenant isolation. So kind of let's look at the tenants that we have in this table, and what I'm gonna do is I'm gonna show you the tenants along with the row count for each tenant. So that's what this SQL query here is doing. So as you can see, I'm showing 20 tenants here, just in the interest of space. And as you can see, I have this one tenant ID 77 here, which has a very high number of row count, around 200K rows. And then I have some other tenants that are relatively smaller. So nothing like the tenant 77 is an orders of magnitude larger than other tenants here. So this is a kind of a tenant that we probably would like to isolate. And I'll kind of demonstrate that going forward as well. So now let's look at which shard ID does this tenant 77 fall in, right? So we have this UDF in Citus. It's called get shard ID for distribution column. So what it tells me is like, okay, so where will this tenant ID 77 fall to? So in this case, we can see that it will fall to a shard ID that ends with 1007. So let's keep that in mind. Yeah. Now I'm going to pick another tenant, 166. And the reason why I've picked this tenant 166 is because it also maps to the same tenant ID, shard ID, my bad. So you can see it ends with 1007, and that's the other, that's the same shard ID as 77. So as you can see, now let's kind of look at the number of rows for tenant 166, right? So we only have 200 rows for 166. So as you can see, we have two tenants, one very small, 200 rows, and another tenant that's very large, 200K rows, both of them kind of being placed in the same shard. So what we want to do is we want to kind of isolate this large tenant, right? Yeah. Just to show you the shard that both of them lie into, that's the range. So both of them kind of lie in the same range, right? So now what I'm going to do is, and one more thing before I get to the tenant isolation, we notice that the shard right now is in my machine, so it's localhost, and I have multiple Citus instances running on my machine. So it's on the instance that's running on port 5434. So that's something that we'll come back to in a few minutes.
Nitish, so what I'm understanding is the two tenants, right? The big tenant and the small tenant are on the same Citus node, right? And is that correct?
So they are on the same shard, yes.
Which is on the same node, right? Like
which may or may not be in the same node, for in the scenario where since they lie on the same since they lie on the same shard, they have to be on the same node. Yes.
Correct. Exactly. And now you would be isolating this large tenant to its own node, right?
Yes.
Awesome.
That's correct.
Yeah.
Cool. So before we do that, let me just kind of show you a sample row count. So this is the row count for my table. And now what I'm going to do is, since we want to highlight the non-blocking aspect of it, I'm going to start running a workload on my table and then perform tenant isolation concurrently. So here I have my PSQL session running. So what I'm going to do is I'm going to copy this, paste it here. And now what I have is I have a workload running, which is kind of inserting data every 1 second. And now what I'm going to do is run tenant isolation together. So here we go. As you can see, my workload is running and the tenant isolation is done. Now you might notice this small error in the end, towards the end when the tenant isolation is about to complete, and that is expected. This is because imagine like you started with one shard and now you're kind of splitting this shard into a separate, like in this case, 3 separate shards. So what we're going to do is we're going to isolate the one the hash range for this one large tenant, and then we're going to have the 2 other shards, and I'll get to that in a minute. So essentially, what I want to highlight here is that we are breaking the source shard into 3 different shards. There's a small window where we switch from the parent shard to the new shards that have been created, and that's where you can see like a small blip. But but overall the operation is non-blocking.
And Nitish, one thing on this aspect, right? Like it is a very short blip, number one. And if there is retry logic in the application layer, right? Like this is like taken care of, right, Nitish? Is that correct?
Yeah, that is correct. So the retry logic will kind of take care of it.
Awesome.
Yes. Cool. So let me show you the new row count. So as you can see, the row count has changed. So we took all the inserts and we just did it without any downtime. And now highlighting the pgdist shard, looking at all the shards in the table, you can see that now I have 34 shards in the table. And I would like to highlight this particular shard here that ends with 1033. And as you can see, the min and max value for this shard are the same, right? So that's where now the tenant 77 has been isolated. So we can verify that with another query here. So what I'm going to do here is I'm going to look at the shard ID for tenant 166, and remember they were previously in the same they were hashing to the same shard before, but now this guy ends with 1034, and then we have this guy ending with 1033. So they are on different shards. So now what I'm going to do is so what has happened is we have kind of broken the shard range into like in the 3-way, and now but the both shards are still on the same node. So what you also want to do is move the shard ID 77 physically onto a different node. If that makes sense. So let's look at the location of the shard. So everything is running on my machine. Everything's on localhost, but notice the port. It's running on the Citus that's on port 5434. What I'm going to do is I'm going to show you all the nodes again in my cluster. So I have a 3-node cluster. But before so what I'm going to do is now I'm going to add a new node and then move the tenant 77 to this newly added node. So I'm kind of increasing my cluster capacity and moving this large tenant out. So let's do that. I just added a node, and if I show you the number of nodes again, you can see I have a new node added here now. And now what I'm going to do is using our shard move capability, move this tenant and the shard to a different node. So yeah, we started with a shard and then kind of isolated it and then moved it to a new node.
And is the moving shards also online, Nitish? Is that also all online?
Yes. So shard move is also online with Citus. So you can kind of go through this entire process without any downtime and without blocking your workloads.
Awesome. I have one interesting question. Shall we run a query on the observations table with that tenant ID filter and run an explain plan? I just want to see where that tenant is, basically.
So what do you want? So you want to
select
say
star from observations where the tenant ID is equal to the big one.
Where tenant ID equals to 77. So that was our
correct. And let's run this first. And then, okay, and let's run an explain on this.
So I think explain on the same query, right? That's what you want to look at?
Correct. Because I just want to see that particular tenant on the new node, which is 5435, right? So yeah. And now if you see the explain plan,
Yeah, so you can see 5435.
5435. So it realizes that, okay, this particular tenant is on that node. So the Citus distributed planner and transparently routes the query to the right node and executes the query. And now this tenant is on its own node. So yeah.
Yep. Cool. So that was tenant isolation. So now let's move on to shard splits. Right. So one of the other capability that we have introduced as part of Citus 11.1 is the resharding capability with this new UDF that we call Citus split shard by split points. It's a mouthful, given, and there's a reason behind it, because it's kind of an advanced UDF, since it allows you to split a shard with precise control over the split factor and the placement. So if you remember in the previous case, we were kind of starting with a tenant, isolating it, and there we were doing a three-way split. This kind of generalizes it, and so more lower level API that powers tenant isolation as well as create distributed concurrently. So there we are going from a single node to in Adam's case we went to a 32 shard table, right? So this kind of just to give you like a more like a deeper, a sneak peek into the guts of Citus. The Citus split shard by split points API kind of powers all the features that you saw, and it's a little more advanced. So it allows you, it allows more control. So you have to kind of give it like more inputs to kind of work with. So to kind of show you like a scenario where we would need this UDF, right? Now I'm gonna run this query on my cluster. What we are doing is we are kind of looking at all the shards that are above a certain size threshold. So in this case, I have since it's like a demo, I have a 10 megabyte limit. In production, obviously this is going to be higher. So what I'm essentially saying is, okay, I have a few shards that are bigger than 10 MB here, and then maybe I want to do something about them, right? So if you look at it, look at the output here. My first shard is the one that we just isolated. So that's the one ending with 1033. It's 15 megabytes. So we've kind of already kind of isolated it, right? And it's on its own dedicated node. The other shard ID, I see one more shard ID here that ends with 1008, and that's again of 13 megabyte in size. So this again, the second shard is another candidate of maybe we want to kind of maybe split it and kind of move it, move individual shards either around or as part of the split itself, kind of place the two the child shards into different nodes. So this is a good candidate. However, if now going back to the tenants, right? If I look at my tenants in the observations table, we already took care of tenant 77. We have a few other tenants, but there's no whale tenant or large tenant, obvious tenant to isolate, right? So essentially, what we are kind of looking here is to take the shard that was 13 megabyte in size and kind of break it down, split it, and then we'll end up with smaller shards, and then we can either move them or we can kind of work with them as we want to. So here's where Citus split shard by split points API comes in. So kind of to give you kind of an overview, what it takes a shard ID. So you have to give it like the shard ID you want to split, and then it takes an array of split points. So since you have as you can see now we get to the control part, right? You have precise control over how you want to split your shard and how many way you want to split your shard. So it allows you to do like an n-way split. So you could do 2-way, 3-way, however way you like it, right? And then for each split child, it also allows you to control the placement. So for each split children, we can say where does it place, right? So in this case, since I have one split point, I'm doing a 2-way split. So I have 2 nodes. So you can kind of control the placement as well precisely. And then the final parameter is the split mode. By default, it's auto, which is non-blocking. So that was kind of a rundown of the API. And now we're going to do the same thing. We're going to run some workload and kind of split concurrently, and then notice how things goes. So to show you the row count again, this is our row count. And then what I'm going to do is I'm going to start running my workload again.
I guess the one thing I want to point out is that splitting shards is not something that Citus users do all the time. I like how you positioned it as an advanced feature, and it's something that you do when you scale and grow your application in some imbalanced way, or just you kind of start to reach limits when you got to break things up. So
this is very helpful when you have one shard that is really growing, and you only have like some amount of runway in terms of capacity, and then you want to kind of handle that. Cool. So what I'm gonna do is I'm gonna start my workload. So my workload is started, and now I'm gonna split this shard. Remember, shard ID was 1008, ending with 1008. And what I'm doing here is I'm picking my split points in a way where I split it right in the middle. So that's what I have here, right? So I have one split point, and then I have a two-way split where I'm sending first half of the data to node 2 and second half to node 1. So let me run that.
Yeah, I'm seeing this feature very helpful when a single shard is very large, Nitish, right? Like this does happen. I mean, not like very common, but it happens sometimes, and a couple of times in the field I have seen this. So
yeah, so your storage or even your throughput needs, if you outgrow your throughput needs, and you want to have the break it in a way where each, like the children can be in its own node, there also it'll be of good help. So again, we saw the writes were just ongoing. There was no blocking happening, and then eventually you might see a small blip where we switch from the parents shard to the child shards, where the workload kind of moves. Again, now just to kind of show you the new shards in the table, I have it ordered by shard ID, so you can see the new shards that were created first. So as you can see, if you pay attention to the first two rows, we have these two new shard IDs. So now our shard count has gone to 35. And then remember, we had a 13 megabyte shard. We have now kind of broken down. We kind of split it in half, and now we have like two shards, which are roughly like 6.7 megabyte in 6.7 megabyte in size. So yeah, that's kind of finishing the whole split, as well as moving it to two different nodes.
This is super useful. We're going to have you back, Nitish. You're going to give demos in future Citus release parties. You're really good at this. This is awesome.
Thanks, Claire. Thank you.
Thanks, Nitish.
All right. Not to kick you off, but I want to get Honor on stage here. And thank you, Nitish. That was great. People can follow you on Twitter and reach you that way to ask questions. Folks can also join the Citus public Slack. And you can get to that link from the footer of any of those Citus website pages. Owner Chatur, thank you for joining us today. You're going to give us a demo on not just shard rebalancing, but shard rebalancing in the background, right? So
correct.
You no longer have to hold that connection open while it's running, right?
Yeah.
Correct.
Okay.
Correct. I will be doing a very short demo switch, but before that, I also would like to give a short context on what we had before in the older Citus releases very shortly. So in the older Citus releases, we were already providing giving the functionality to our users for them. The ability to rebalance their shards by using the rebalance table shards Citus function or the command, and it was very nice. But the thing is, it was requiring users to hold their client connection to the Citus coordinator open until the very end of the shard rebalancing operation, meaning that they were previously required to wait until all the shard moves to be done before leaving their coordinator. And but for example, this was resulting in, to achieve this problem, users, one workaround to this was to spin up an Azure VM, for example, that is close to the Citus coordinator and start the rebalancing in a tmux session or something. And so with this release, we made really a good amount of improvements to better improve this situation. So it's time to demo.
Awesome. Show us.
Okay. So for the demo purposes, I already created an events table, which is which is a distributed table, which I can like to see. Like, let me create the sites tables view, which will show me the events table, which is distributed based on the event ID and which is of size around like 7 gigabytes.
Mm-hmm.
And like, if I also query the sites, or if I also do query the PGRD's node view, which will now show us the network sites cluster topology, we have only we only have a one and only single worker node in our sites cluster, which is hosted in the localhost and on the node port 10,701. And as in the as in usual user use case, and I decided now I would like to scale up my sites cluster even more. So I first want to add another worker node into my sites cluster, and for which I use the site set node UDF, and right after that I will use the sites rebalance start function to start the shard rebalancing in the background.
And I guess I should point out that that's like the most obvious time that people use the shard rebalancers, when they've just added a brand new empty node to the cluster, right? And you got to spread things around.
Correct. This is because, like, when you add a new table, when you add a brand new worker node into your cluster, you would probably most likely to need to balance the load in between, like between
Sure.
those worker nodes. So that is why you would like to rebalance your distributed tables. And after and before starting that, before executing that sites function, let me also give some information about that too. Unlike the sites, unlike the rebalance table shards function that we had already, this function, the sites rebalance start, immediately turns the control back to the user, meaning that now the user doesn't need to hold the connection open until the end, but instead Citus will be maintaining, or will be really managing the whole rebalance process in a background process in the server side, basically. And that function, as a result, will return back to me a select query in the hint part that I can use to monitor the progress of the shard moves required to rebalance the Citus, my Citus setup. So let me start with this. Yeah, now the rebalancing process start in the background, and I will be using that select query to monitor the progress. And here, what I see is Citus decided to, like, my table had 8 shards, and Citus decided to move 4 of those 8 shards to that brand new worker node. And here, what we see is it already start moving the first shard, and the other 3 shard moves are waiting for the first one to be complete.
So the status of blocked just means that those shard moves have not yet started. Is that correct?
Exactly,
Okay.
Claire. Yeah, and while doing that, I would like to do 2 things. First, I would like to detach from the coordinator to show that really the fact that the rebalancing process is still happening in the background. And the second thing I would like to do is I'd like to restart one of my worker nodes to simulate an intermittent a failure, like a network failure between the worker nodes, or some other kind of failure, while the rebalancing is in progress. Yeah, so now let me connect back to my sites coordinator, which is hosted in the very same machine, in my local machine, on that port number. And if I do run the very same query again, I can see that first shard move is already completed, and Citus now is moving the second shard. And if we have a look into some other columns of that catalog table, we can see that the second shard move first stopped due to that error, which is which is just because me restarting that worker node for some administration purposes, for example, in the real world. But this doesn't this is not a problem for sites since
I have one wish, Honor. I have one wish. Can we actually, like, not to put you on the spot, can we do an insert into this table while the rebalancer is going on?
Sure. Yeah, sure. Insert into events, and let's say the value is -3, and then event resource 5. Yeah, it was also fine.
And so when basically when the rebalancer is running, like it's all online, so the application can do reads, writes as expected, right? Is that correct?
Correct. No writes or reads are blocked during this rebalancing operation. Correct.
And then I just want to remind everybody, if you haven't paid attention to Citus in over a year and a half, the shard rebalancer is completely open source and has been since Citus 10. So that's like spring of last year. So everything we're showing you now is available in the open source extension to Postgres.
Yeah. And with this feature, Onur, like, I mean, I see like two main benefits. One is like from a usability standpoint, like it's all in the background and customers need not worry about errors. They can just like, kick off the rebalance and go have coffee, like enjoy the evening, etc. Right? And under the covers, like the scale out would just happen on its own. That is one. The second thing I like is the operational visibility also. This was a surprise for me where like when you killed the node, right, like it even showed the error that, hey, there was an error, but still I continued from where it was before, right? So that was pretty cool, Onur. So yeah.
Did you show the retry count?
Yeah, I will also show that in a few seconds. And,
okay. I'm jumping ahead.
Yeah. And while Sai also mentioned like the visibility things, like Sai, we introduced a few more catalog tables into Citus, such as the PGDIS background test to give the ability to better or easier monitoring to our users. And for the retry counting, for example, Citus was supposed to move 4 shards out of the first worker node. And if we again have a look into the other columns of that catalog table, we can see that retry count is equal to 1 for that second shard move operation. Meaning, and this is again just because like me restarting the worker node for no reason, and this also and luckily this also means that Citus was able to recover from that failure by retrying that, and at the second trial it was just done, and we can see here like all the shard moves are done. And for the sanity check, let's just query the Citus shards view one more time to see that where our shards are living right now. And we can see that we had 8 shards, and 4 of them are living in the first worker node still, and the other 4 are moved on into that new brand new worker nodes right now, and like we don't see and we didn't suffer at all from the failure in the worker nodes.
Awesome.
Yeah.
So one last question, and then we're going to bring everybody on to say thank yous. Is there a way to stop and pause and then resume the shard rebalancing operation? It's a legitimate question. I don't know the answer.
Yeah, we have like similar to Citus rebalance start function. We also have one other function which is called as Citus rebalance stop, which allows users to stop the rebalance operation. But if I'm not missing, if I'm not missing something, we don't provide a functionality to resume a rebalance operation that is interrupted by the user itself, themselves explicitly. Like in case of a failure, Citus tries, but
I had a question, Onur. Like, would rebalancer, if I start rebalancer again, would it continue from where the user stopped?
Actually, this is very. It would be very good to test it, but I didn't test this actually, to be honest, Sai. Yeah,
I think it would. So, like when you stop the rebalancer and restart, it would continue from whatever shards that were not moved. Only those would be moved. The shards that were moved, like you're all good. So Yeah, so it is kind of a resume, Claire, to answer your question,
Okay.
right? Like so.
Awesome.
Correct.
Well, let's bring everybody back on so we can say a quick thank you. I know we're a little bit over time today, so I guess we went a bit long in some of the demos, but that's all good because we all love demos, right? Adam, Nitish, owner, thank you for joining Sai and me today. And folks can go to the GitHub repo. There's a great README there with instructions about installation and more information. You can also star the GitHub repo too. Always love that. And there's a bunch of other links on the screen right now as well. The Citus public Slack is a great place to ask questions, as well as Stack Overflow. And the release notes and all the details and the docs, which are great, thank you, Joe Nelson, are all available on the website. Citus is, of course, also available on the Azure Managed Service, and we'll be getting 11.1 available there very soon now. So it's not there yet, but I expect it to be, certainly we're at the end of September, so certainly in October sometime. Cool. Thanks, everybody. Sai, did I miss anything?
No, I think that was great. I was very excited with the demos. I might have asked a lot of questions, but I mean, always demos exceeding the time means that it's a lot of fun. So thanks guys for taking the time. This was so interesting.
Thanks, everybody.
Bye.
Thanks,
Ciao, ciao.
Bye.
Bye.
Thank you all. Bye.